So tolerance. Let's read a little bit and highlight, and then I will give you some examples, real life examples perhaps, that will make this a little bit more manageable for you. So obviously when you hear the word tolerance in everyday language, when you tolerate someone, you put up with that person, right? There are certain things that annoy you about that person, but you just tolerate, you just kind of like just you put up with it. So it's not quite where you would want that person to be, right? So kind of same idea here. So when building or assembling any object, from a simple bookcase to a complex computer, I would say a car, engine, anything like that, an airplane, your measurements should always be as accurate as possible, and they should be precise enough for the needs of the project. When manufacturing a product, a range of sizes are often acceptable. Range of sizes are often acceptable. For example, if you're making a mortise and a tenon joint, you have no idea what that is. I'll explain that in a bit. The tenon needs to be small enough to fit the mortise, but large enough that it will not fall out. Okay? The range in acceptable values is called tolerance. That is what I want you to focus on, that part. Okay? So this is an example of tolerance, and this is the definition of tolerance. Okay? That's the definition of tolerance. And this is an example. So for example, when it comes to your COVID vaccines, our COVID vaccines, maybe you didn't get one, that's fine. But if they give you too little of a dose, it's not going to be effective. If they give you too much, it could be dangerous, right? And so tolerance, there is tolerance. So anybody remember what a dosage, how many milliliters are in there? I think it's 0.5. And maybe it's 5 milliliters or 0.5. There's a big difference, but I'm off. I have to double check that. But they aim for something, and it could be that you're off by a little. The syringe that they use might be off. Maybe the nurse's vision, it's like the end of shift, it's not seeing properly the line, in the liquid lining up. It could be a bunch of things, but you could be off by a little bit, but that's okay. They make up, like they have a certain tolerance. Your body is okay getting a little bit more and a little bit less, but there's a limit to it. Okay. I'll give you another example. Anybody know the outlet there? What's the voltage coming out of that? Out of your plug? 120, 115. It's not being on. It's not like they're telling you 120. It's always going to be 120. I used to do this, and maybe I will. I usually plug in an extension cord, and right here I have my voltmeter, and I show you that it fluctuates. Like it's not always going to be consistent. So your electronic devices, your TV, your computer, all of that has to make up for it, right? They have to allow for the electricity to go to 130 or go down to like 105. They need, because if it's too low, your TV is going to shut off, right? It's not going to work. If it's too high, what's going to happen to your electronic device? It's going to fry it, right? It's going to flat out fry it. Maybe some of you had that happen, right? Like maybe lightning struck the power lines close to your home. That's another story. That's too much, right? That's a surge, right? But it happens all the time. Tolerance is everywhere, and if manufacturers don't account for that, there's a big problem, right? All right. For example, tires, right? Tires can be off too. If you measure the pressure, it could actually be a little bit less and a little bit more, and your car should still function properly. So there's tolerance everywhere. So let's keep going. I want you to box this in because this is another definition of tolerance. And I also want you to box in this. It's a new term, nominal. Nominal, I want you to just go nominal is the target. What we're aiming for. And here, tolerance, right? The variation allowed so that it's still acceptable. And I'll tell you this, like I used to, I told you, you know, I worked at Kitchen Craft most likely by now, but there was a time I ran a big machine. It was called a Raymond Ripsaw. So I would feed boards to it and it would scan it, take a picture, and there were 7 blades on that machine that moved. And so they would scan it and I would see imperfections in the board, and that machine would automatically move the blades and feed that board and cut out the imperfections. It would like optimize it, right? And so I had to measure a piece of wood. One of the sizes that they wanted was 45 millimeters wide. That was the nominal. That is like my target. But do you think every single piece when I calibrated that machine was 45 millimeters? Nope. It was 44, 46, sometimes exactly 45, sometimes 45.7. And that was due to many factors. Like the blades, they vibrate, they get dull, sometimes they bend a little bit, sometimes there were shots inside the boards. And if it hits the shot, then the blades are off, and then you have to consistently check, is everything coming out right? Because we're talking hundreds of thousands of dollars worth of wood just coming down the line, right? So the company, you can get fired if you don't catch that in time, right? So they aim for that, but they told me if you go down to 43 millimeters, we're still good. If you go up to 47 millimeters, we're also still good, right? So there's a min and a max, right? There was a low and a high value they allowed for. And that difference between them is called tolerance. Oops, what happened there? Switched to a different language. Tolerance, right? So that's what we're going to talk about today, and it's actually not too bad. And this diagram, which is that piece right there sticking out of this wood piece, is called the tenon. So if you want to write that down, anybody in woods in here? Did you make this at all? Like it's maybe you use a different one, right? You use mortise. I don't. What kind of joints do you use these days? You do the.
We don't really use joints.
Okay, got it. But some of your furniture, like your chairs, they're built this way, right? And then they're nailed yet and glued, and so it's a really tight fit. But if this is too small, it's going to be loose inside, right? Inside that mortise. If it's too big, it's just not going to fit flat out, right? So there's a little bit of um, leeway there, and you need to account for that. Okay. Watch here. The tolerance is determined by subtracting the minimum and the maximum acceptable value. So here's the first formula for you. None of these formulas are on your formula sheet. So you need to have this. Tolerance is essentially max minus min. That's the amount of the difference between the two. It could be temperature, it could be PSIs, it could be length. Exactly. It is the same as range. But right now we're in tolerance, and I will explain later what the difference is. It's because of the precision and uncertainty issue that we allow for the tolerance, because we can be off. Everybody can be off. When I use my caliper to check, I could be off. Down the line, somebody could be off. So that's why we allow for tolerance. And by the way, I was at the beginning of the process. I worked with raw lumber. As you went down the assembly line, the tolerance became smaller and smaller. So I was able to be off by a lot because the machines that fed those pieces, they would machine it even further, right? So even if you were off by a little bit, the machine would take care of that discrepancy. As you go down the line, it has to be exactly. Otherwise, your kitchen is going to look all wonky, right? It's not going to look nice when you make your doors. So that's another thing that you need to know. When unknown, we assume that the nominal value, it's only when it's unknown, right? The nominal value is halfway between the min and the max. And please write this down. Nominal, which is my target, by the way, guys. It's just a fancy word for what we're aiming for. You would take your max and your min and divide it by 2. Make sure the top is done first. That's why I'm going to put the brackets there. But I want to make sure this is, you know, that when unknown, this is happening. Other than that, it's going to be a lot easier to figure out. I'm telling you already. It's going to be a lot easier. So tolerance can be written in 4 ways. And these need to be on your study sheet. Okay, I'm not going to box it in just yet. So I'll just give you examples. Let's say it's written like this. So let's say we use temperature for an example, 27, negative 2 degrees Celsius. So that would be an example of this. So I will kind of block this off there. If you see 2 numbers stacked, you know it's in this format. If you see it like this, you will recognize it by just looking at how it is written. So let's say you get 45 millimeters plus or minus half of the tolerance. So let's say it's written like this. You go to your study sheet. The only one that looks like it is this one. This is it, when you see the half thing there, you know it's that one. There's no doubt about it. And let's say this one here, you get a minimum value. You can't go any lower, so it's indicated by going minus 0. You can't go any lower than that, and usually you have to have units there. But you could be going higher if you wanted to. And let's say this is 4 millimeters. Block that off as well. So think about it. This is the minimum. This is the lowest value you can possibly get. You can't get lower, but you can get higher. And the example I use here is, for example, a runway for an airplane. I'm sure they have a guideline. It can be this long. It cannot be shorter. It's okay to have it longer, but do not make the runway shorter. So that would be like a tolerance there. The next is the max, which is 47 millimeters. You can't get any higher than that, right? So that's the max, but you could go lower. So I look at this one, and this is the one that I would use in medicine, right? To not get an overdose, it's okay to be off on the low end, but you better not be off on the higher end, right? Okay, this is where the province, like I remember when we had market training, this was a big issue, right? So what they told us that the front number, the number at the front, and I'm going to use a different highlighter because it's important. They told us that in every single case when you have a big number in front, and notice that this one here on the left does not. There's not just one big number in the front. These 3, those are always going to be our target. So it's the nominal. Write that down, nominal or target, every single time. We're just going to assume that that is the case. That in reality, a company or a production line, they would be aiming for that number, and it could be off, but they're really aiming for that. So you're like, Mr. Erickson, so this one here, you told us that this is the max. The answer is yes, but it is also what they're aiming for. It's both. Here it's the min, but it's also the nominal. It's what they're aiming for. Here it's the nominal, and we know it's the nominal, right? Because it fits the description. Okay, but every time you have the big number, boom, you know that's your target. Now let's put this into practice. And I'm going to give you 4 examples. I'm going to kind of take my time with those, but that's going to be it for today. And then tomorrow we'll put it into practice. So 93. So just pay attention. Every single example is separate from the previous one. Okay. So let's say you get 15 centimeters and 12 centimeters. It's written like this. This is on page 93. Every single time, guys, you can get the max, the min, the tolerance, and the nominal. Every single time. Any format that I give you, you can draw these 4 pieces out every single time in no particular order, but you can do it. So you would go to your study sheet and you're like, imagine this isn't there. You go to your study sheet and say, oh, 2 numbers stacked. So I'm going to go look at my 4 ways, and it looks like this, right? So we know that the top number is my max. So just read it off. Just fill that in. The bottom number represents my min. So just fill that in. There's a reason why I'm doing this, so just trust me. Tolerance. The tolerance is what? Max subtract my min. Right? I will just subtract those two. So 50 minus 12. We're talking 3 centimeters, right? That's the tolerance that they allow in this case. And the nominal, do we know the nominal? We don't. We don't. Let me just go back once because it's important. In this case here, nominal is unknown. Nominal, unknown. Only this case. So what do we need to do when the nominal is unknown? Max plus min divided by 2. You're really finding the average between the two. Let's go back to 93. So we're going to go max plus min divided by 2. Can we write down unknown on here? In this case, it's unknown to us. So you take your max and you take your min and you divide that in half. You get 27 divided by 2. Right? You add these up, divided by 2. That's 13.5, and we're in centimeters. This is the only time you're going to have to use that method when it's the max min like that, 2 numbers stacked. Okay, now cut this because it's completely different from the next example I'm going to give you. So the next example is like this. Write it down. 17.5 millimeters plus or minus 1/2 times 0.4 millimeters like this. So obvious, this is the one that I call the most obvious one of all. Out of the 4 ways, the half gives it away. Right, boom, you're gonna, so imagine this wasn't there. I just gave you this one. You go to your study sheet, I have my 4 right there. This one looks like that one. So I will say, okay, let's go max, min, tolerance, and nominal. Which one should you grab first in this case? I used a green highlighter earlier. Grab that one first, the big number up front. So I put that right there, 17.5. And then I worry about the rest. Do you notice that whatever's inside the brackets represents the tolerance? So you can actually write that in here just like that. You don't have to do any calculation there. I'm going to use orange for that. Okay. Just boom, boom. I read both of these. I didn't do anything. Usually you'll be able to read at least two right off the bat. And here's a bit of a challenge. Not really, but 17.5, you got to go plus to get your max, right? Plus 1/2 times 0.4. So make sure when you multiply something by half, what are you really doing? You're dividing it by 2, right? So I'm going to go 17.5 plus, divide this in half, that's 0.2. So that's 17.7 millimeters. 17.7 is the max. Okay. The maximum allowed measurement. We don't know what this is for, but 17.5. Oh, sorry. For the min, I gotta go minus, right? I gotta go minus 1/2 of 0.4. So that's 17.5 minus 0.2, which is 17.3 millimeters. 17.3 millimeters. And let's say you miss the fact that this is your tolerance. You could still go max minus min and still get the same answer. So it's not like it's a big deal if you don't see it. You just have to watch out for it. Close this. Again, I'm going to give an example here. Let's go temperature. Let's go like that. 5 degrees Celsius minus 0 plus 2. Again, I told you already, every single time, you're going to be able to take these 4 things out of it. And when there's a big number, guys, please remember my words. That is your nominal right away. The front number is always going to be our target. And then the rest you have to figure out. And this, if you notice this format, it's a little bit butchered up here. I apologize. It's like minus 0 plus tolerance. The plus is supposed to be a little further over, but that's okay. The tolerance is 2 degrees Celsius. It's right there, right there. And then the max and the min, you're going to have to calculate. So let's say the max is 5 plus 2, right? 5 plus 2. So it's 7 degrees Celsius for that one. And the min, what do you think the min is going to be? Let's say you miss it. 5 minus 0. I'm just going to go through the motions here. It's 5 degrees Celsius. It happens to be the same as your nominal. So the company's aiming for it, and it's also the lowest they will allow for. So I'm thinking one of those grocery distributors. Have you ever Like they drive in there with those pallet jacks and it's super cold in there. They're all wearing their coats even in the summer, right? Because it needs to stay cool in there. It can't get too cold, but you know, they allow for some variation. When you open the fridge, temperature in the fridge drops, so it'll go up a little bit, but needs to go back down. Let's do the last one here. Leave a little bit of room because I will give you one more after this one, a wonky one. I call that a wonky one, but it's not really that bad. So 0.5 milliliters plus 0 minus 0.1. So again, you should recognize the 0 being on top, right? You should recognize this format. So then you get your max, your min, your tolerance, and the nominal. Leave a little bit of room below this, okay? First thing I want you to grab is this one, right? So 0.5 is what we're aiming for. The tolerance, if you recognize that bottom number, you have to be careful there. But the wonky one will take care of that. Anyways, 0.1 milliliters. The max, you should recognize that this is the max, because even if you go plus 0, it's still 0.5 milliliters. The min is 0.5 minus this number, and that's 0.4 milliliters. And hold on, the wonky one, the one that's going to throw you off if you don't have that example, because this is also because the province did that. So it will take us 3 minutes. Watch this. 45.05 centimeters minus 0.03 centimeters plus 0.02 centimeters. What's going on here? I call this one no name. Like we don't have a specific format for this one. But guess what? I know you're thinking it. I wonder if this is still the nominal, and you thought right. You got it. So the nominal is still there. Can you say the tolerance is 3 or 2? The answer is no. You can't do that. So what you do is you take the max, you figure out your max, you add the amount you can go up by. So that's 45.07 centimeters. Then you take the amount you can go under by, 45.02 centimeters. Can you tell that it's going to be 5? You could have seen it here, that the difference between the lowest and the highest is 5, because that's what we do to figure out tolerance. If you're not sure, just do that. So that's 0.05 of a centimeter. Oops. Zoom out. And that's it.